Welcome class to our first online lesson. We're going to be working out of a different textbook for this unit while we're doing this distance learning. So if you have all your materials, your books at home, keep those. When we come back to school, we're going to go back to our normal lessons. But during these 2 weeks, we're going to complete a unit from a textbook that has some online capabilities. So as far as the videos, you should be watching the videos and taking notes. You will still get a notes grade. So if I'm writing, you're writing. If you need to catch up, just hit the pause button, catch up, and then move on. If you have any questions throughout the lesson, you can always reach me through a phone call, text messaging, and or email. I'll respond from 8 to 4 right away. Anytime after 4, I can respond at, depending on my schedule here, and so forth. So without further ado, let's get started. This first lesson is 10.1 triangles. So let's recall some information. We've already done the lesson on triangles, so this should be relatively easy for you, a review. Remember, by sides, it's equilateral if all the sides are congruent on that triangle. And isosceles if two sides are congruent on the triangle, and scalene if none of the sides are congruent of the triangle. We can also classify the triangle by its angles. So if all the angles are less than 90 degrees, it's an acute triangle. If it has one angle that is equal to 90 degrees, then it is 90 degrees, then it is a right triangle. And if it has one angle that is greater than 90 degrees, then it is called an obtuse triangle. So let's get started on the first example. I know I'm kind of rushing through this. I'm trying to get everything in and out today. So let's look at the first example. The measure, find all the angles and classify. So it tells me that the measure of DBE is equal to 64 degrees. Whenever I'm learning some information, I should go ahead and plug that into my picture. So remember that B is the vertex we're looking at here. Measure DBE here is 64 degrees. And then it further tells me that the measure of BD to E, so B to D to E here, is going to be the same as BE to D here. So I know that these two angles are congruent, but I'm not sure what each of those is. If you don't know something, we should use a variable. So let's plug in x. And if this angle D here is x degrees, then we also know that angle E is x degrees. And from our last chapter, you should recall that triangles, the triangle sum theorem says that all three angles of the triangle are going to add up to be 180 degrees. So let's write that equation. 64 plus x is equal to 180 degrees. I have all three angles, 64 degrees, and x degrees, are all going to be equal to 180 degrees. So let's combine our like terms. 64 plus 2x is equal to 180 degrees. Now I can subtract here, subtract 64. 64 minus 64 is 0, so now I have 2x is equal to 116. Divide both sides by 2, and I am now left with x is equal to 58 degrees. The question says to find all the angles and classify. So I know that one angle is 64 degrees. I know that another angle here, x, is going to be 58 degrees. And the third angle here is also 58 degrees. If I look back at my names of my triangles, all of my degrees are less than 90 degrees. Therefore, this is an acute triangle. In this next example, we're given a word problem. The perimeter is equal to 65 centimeters. Remember, the perimeter is the distance around the triangle. The distance around the triangle, meaning we're going to add up all three sides. So the sum of all three sides is equal to 65 centimeters. The length of the first side is twice the length of the second side, and the third side is 20 centimeters. Find the lengths and classify. So to begin this problem, I would start by drawing a picture of a triangle, so I can start filling out what I do know. I know that the perimeter, or the sum, is going to be 65. The length of the first side is twice the length of the second side, but do we know what the second side is? No, so we should use a variable. So let's call the second side here, I'll call side 1, 2, and 3. So the second side we'll call x. And it says the first side is twice the length of that second side. So twice means 2 times. 2 times x. And then it tells me straightforwardly that the third side is 20 centimeters. So this third side here is going to be 20 centimeters. Now I have enough information to write an equation and solve in order to determine the lengths of all three sides. So if I add them all together, side 1 we said is 2x, plus side 2, which is x, plus my third side, which is 20. That should all be equal to my sum of my perimeter, which is 65. Now I will combine my like terms. 2x plus x is 3x, plus 20 is equal to 65. Okay. Subtract 20 from both sides. Bring down your 3x is now equal to 45. Okay. Finish by dividing both sides by 3 in order to solve that x is equal to 15. However, this is not the answer to the question. We need to find the lengths of each of the sides and then classify. So in order to find, I know that the first side here is going to be 2 times x, which we just said that x is 15, so 2 times 15 is 30. So the first side is 30 centimeters. The second side here is x, which is 15, so it is 15 centimeters. And the third side it already gave me as 20 centimeters. So now I've found the lengths of all 3 sides, 30 centimeters, 15 centimeters, and 20 centimeters. Now that I know all 3 lengths, I can classify. Are any of them the same? The answer is no. Therefore, this must be a scalene triangle. In this next problem, we're given some angle measures. Okay, so the ratio of these angle measures is 1 to 3 to 5. Let's find the angle measures. Wow, where do we begin? Well, we are given some very valuable information in this ratio here. That the first side, for every one in the first side, I have 3 in the second and 5 in the fifth. I know that all 3 of these, because they are angles of a triangle, are going to add up to 180 degrees. So I can start by writing the right-hand side of my equation. Now, I don't know, I have 1 of what? I don't know, so I can use an x, a variable. So I have 1x plus, I know for every 1 of my first side, I'm going to have 3 to my second side. So if I have 1x, then here I should have 3x for my second side, and similarly 5x for the third side. So I have side 1, which is x, side 2, which is 3x, and side 3, which is 5x. I know that if I add all 3 of these angles, I'm going to get a total of 180 degrees. So now let's combine our like terms. X plus 3x is 4x, plus 5x here is 9x, is equal to 180. Finish solving by dividing by 9, and x is equal to 20. Now it says to find the angle measures. Well, remember, this here is from angle number 1. This here is from angle number 2, and here is from angle number 3. So now I can plug in those values of x. So angle 1 is going to be x, which is 20 degrees. Angle 2 is going to be 3 times x, which is 3 times 20, 60 degrees. And the third angle is going to be 5 times x, which is 20, so it should be 100 degrees. And you can check by adding these up. 20 plus 60 plus 100 is going to give you your total of 180 degrees, which we know we need in order to make a triangle. Now look at these 3 here, 20 degrees, 60 degrees, 100 degrees. If I asked you to classify this, what would you classify this triangle as? If you answer obtuse, you are correct, because it has one angle here that is greater than 90 degrees. Therefore, this 20, 60, 100 degree triangle is an obtuse triangle. In this last example, we'll be asking the question, do the sides create a triangle? In order for the sides to create a triangle, you have to have the small side plus the other small side must be greater than the largest side. Must be greater than the largest side in order for it to be a triangle. So let's look at an example. If I tell you that I have the sides 6, 7, and 9, will this triangle that has sides labeled 6 units, 7 units, and 9 units, can we then form a triangle? So let's look here. If I add the 2 smaller numbers together, 6 plus 7, okay, that's going to equal 6 plus 7 is 13. Is that greater than 9?